my name is Nicholas Andrews, and this is my submission for Physics 2211 Lab 4 on oscillations. The purpose of this lab is to predict the motion of a mass attached to an oscillating spring. First, we analyzed and tracked the motion of a mass attached to a spring using the video tracking software Tracker. Using the data from Tracker, we derived the necessary parameters to predict the spring's motion in PHYS. Here's a preview of the results. We compared the changes in energy in the X and Y positions between our model and the experiment. Possible sources of error include neglecting air resistance and rotational motion, which could slow the spring's motion and affect the accuracy of our model over time. Newton's second law and the energy principle are critical physics principles used in this lab. Newton's second law helps derive the position and velocity update formula needed to predict the spring's motion, while the energy principle calculates energy changes through the spring's motion. The system in this lab consists of the Earth, the mass, and the spring. The surroundings are considered negligible, meaning no external work is done on the system, and thus the energy change is zero. Initially, the mass starts at rest. In Tracker, we tracked the spring's motion and recorded each X and Y component. From this data, we derived the spring constant and the relaxed length of the spring by measuring the time for one oscillation. After calculating the spring constant, we used GlowScript to predict the motion of our spring. The initial conditions are the spring constant and the relaxed length we calculated. We then observed the spring's displacement and applied the energy principle. Through each loop in our simulation, we set the system's initial energies and calculated the net force, which is the sum of the spring and gravitational forces. Knowing the net force, we updated the mass's velocity and change. The energy principle calculates energy changes as the mass moves along its path. We compared the changes in the energy and the X and Y positions between our model and the experiment. Possible sources of error include neglecting air resistance and rotational motion, which could slow the spring's motion and affect the accuracy of our model over time. What does it mean? The energy principle was satisfied as the rise in one type of energy was accounted for by a decrease in another, keeping the system's total energy constant. Variations in the oscillation period, possibly due to tracking errors and air resistance, impacted the spring constant and potential energy calculation. That concludes my lab report for Physics 2211 Lab 4 on oscillations. Thank you for watching.